Welcome back to another lesson from Hartlepool College of Further Education in GCSE Maths. This one is week 6 and this is dealing with equations where there is an unknown on both sides. Before we start that, however, usual revision grid. So on the next slide there will be a series of questions. When the slides appear, answer the questions and then I'll talk through some answers. Same for the slide after that. Right, pause video now, attempt the question. Okay, so working through this one. Looking at the top left hand corner, we've got workout and then we've got a couple of big maths questions. Remember, B for brackets first, so 7 times 7 is 49. 2 times 49 will be 98, then add on the 2 gets us 100. Then for the second one, 42 divided by 6 is 7, and 7 times 2 is 14. Next up, fractional amounts. So what is 4/7 of 350? 350 is quite a key number there. It's 10 times 35, which is in the 7 times table. So I think 7 times 5 will get me 35, so 7 times 50 will be 350. So step 1 will be 350 divided by 7, which gets us 50. So that's 1 part, or 1/7. And then we'll say, well, that's 50 times 4 to get 4/7. That gets me 200. You're working in pounds, so don't forget units. Next up, we've got a couple of multiplications. So 11 times 11 is 121, and 12 times 7 is 84. Next up, some percentages. So 15% of 65, start with 10%. So I think, well, 10% will be £6.50. We want 5% as well. So 5% will be half of 10%, which would be £3.25. Add the two together, gets £9.75. Then for the next one, we want 30% of 320. So again, working increments of 10%. 10% would be 32. We want 3 lots of that. So 3 lots of 32 is 96. Again, working with pounds, so £96. Next up, the number machine. Input is 70. So divided by 2 gets you 35. Take away 5 gets you an output of 30. Starting with the output, we're doing the inverse operation every time. So starting with 15, doing the opposite day. Add on the 5 to get 20. Multiplied by the 2 to get 40. So the input for that one will be 40. Easy to self-check. Start with 40 divided by 2 gets you 20. Take away 5, these were 15, which is what you were asked to start with as the output. Next up, write 72 as a product of prime factors. So starting with 72, let's split that into a 2 and a 36. 2 times 36 is 72. 36 would be then split into a couple of things, but let's do 2 and 18. And then do 2 and 9, and finally you've got 3 and 3. So we've got 3 2's, so that's 2 to the power 3, and we got 2 3's times 3 to the power 2, or 3 squared. So where we've got 2 cubed times 3 squared, that's in index form. If you've written 2 times 2 times 2, or 3 times 3, that was your product of prime factors. I've just written it in index notation to abbreviate. Next up, working with hundreds and thousands. So 21.3 times 100 is 2,130. 3,486 divided by 1,000 is 3.486. Next up is the factors of 20. So remember, I always try and do this in pairs and always start with 1 and the number itself being 20, and then think, well, 2 goes into 20. How many times? 10 times. There's my next factor there, 10. 3 doesn't go because your nearest multiples would be 18 and 21. 4 goes. 4 goes 5 times. Next number is 5. You've already covered that, so that's all your factors, all 6. And then we've got some fraction arithmetic. So remember the process. Multiply the bottom 2 numbers. So 4 times 5 is 20, and then cross multiply. So 4 times 1 is 4. 5 times 3 is 15. We were adding these together. 4 add 15 is 19, and we're working in 20ths. Can't simplify it, so there's my answer. Next one, same process again. Multiply the bottom 2 numbers together. So 5 times 3 is 15. And cross multiply 3 3's is 9. 5 times 1 is 5. This one was a subtract. 9 take away 5 is 4, all over 15. And again, can't simplify. So there's our answers for the number grid. Next up, some algebra. So we start off with some simplifies. X and 3x is a total of 4x, because remember, in front of the x is really a 1 because it's 1x. Next up, 2y and 3y will be 5y. Take one of those y's away, and back to 4y. Next up, some equations. X plus 2 equals 19, or working backwards, I think 19 take away 2 is 17, so x must be 17. The next one, 2x and 16 equals 20, or working backwards 20, take away the 16 is 4, divide by the 2, gets you 2, so x must be 2. Some stuff on laws of indices. So remember, d on its own is d to the power 1. When you're multiplying, you're adding the powers, so 1 and 3 and 1 is 5. So that's a total of d to the power 5. Next up, do the numbers first, or the big numbers, the whole numbers I should say. 4 times 5 is 20, times d squared is 20d squared. Some more equations. 3x minus 5 equals 10, or working backwards, that is 10 to the opposite. Add on the 5 gets you 15, divide by the 3 is 5, so x equals 5. The next one, it's a bit of an odd one. It says x squared minus 1 equals 8. Well, working backwards, 8 add on the 1 is 9, so what we do know is that x squared equals 9. Same as saying x equals the root of 9, so x equals 3. Next up, 5ab and 2ab is a total of 7ab. 3ab take away, remember that's 1ab, leaves 2ab. 36 divided by z, a number equals 9, so I think 9 times something must be 36, and it's 4. 9 times 4 equals 36, so z equals 4. Another one, we've got 25 divided by something equals 5, or working backwards, 5 times what gets you 25? 5. Z equals 5. Next up, factorize. We've got x squared plus 4x plus 3. We want it in this form. Now, if you've not seen one of these yet, don't worry, there's a lesson coming on next week. It's just a bit of fact finding for us to introduce it. We need two numbers that will multiply together to get 3, but in some way add to get the 4. So think of your factors of 3. You've got 1 and 3. It's a prime number. Those are the only two factors. Do they add up to get 4? Yes, they do. So those are the numbers we need, 1 and 3. Next up, expand. So double bracket. So let's work out FOIL first. So we've got y squared. We'll do the fourth outer. So y times minus 3 is minus 3y. We'll do the inner. So 7 times y is plus 7y. And then we do the last. That is the last term in each bracket. So 7 times minus 3 minus 21. Okay, if you've got that far, well done. We can simplify the middle two terms by combining them. So minus 3y at 7y, simplify down to 4y. So what you're left with is y squared plus 4y, so it's a positive value, minus 21. And then finally, we have this formula. It says t equals half, then a plus b in brackets times h. Well, it's actually the area of a trapezium, that formula, but all we need to do is substitute in some values. So really that is t is equal to half times, and then in brackets, a plus b, where a is 4, b is 6, and then we'll multiply it by h, which is 3. So I think 4 add the 6 would be 10, times 3 is 30, times the half is 15, so our answer will be 15. And again, that same method can be used to work out the area of a trapezium, where a and b are two parallel sides, and h is the perpendicular height difference between the two. Okay, so today we're going to be doing solving equations with x's on both sides, but I thought we would just quickly recap solving two-step equations. We've done a few of these on the grids, but just briefly remember what that is. The process is, starting with the x, I need to multiply it by 5, and I'm adding on 8, and my answer must be 43. So working backwards, that is 43. Take away the 8, leaves me with 35, and 35 divided by the 5 gets me 7. So what we can say for that one is x must equal 7. And that makes sense because you think 5 times 7 is 35, add the 8, make it clear we're doing that first, it gets us that 43 we were looking for. We'll do one more. So we got solve x over 5 plus 2 equals 6. Remember that is starting with x. We're going to divide whatever it is by 5. We're going to add on 2. Now answer must be 6. So working backwards, starting with the 6, we do the opposite. We take away the 2, gets us 4. Then we do the opposite. We multiply that by the 5. So 4 times by 5 gets me 20. So x for that one must equal 20. Which again makes sense because if you start with 20 and divide it by 5, you've got 4. Add on the 2 gets you 6. And that's what we were aiming for. Okay, I'll do one with expanding brackets as well, just to complete the recap. So remember, step 1, we expand the bracket, so that's 3 times 2x gets us 6x, and then 3 times 2 gets us 6. It's all equal to 18. So then just work backwards. So 18, take off the 6, 18 take 6 gets us 12, and then we'll divide them by the 6. So 12 divided by 6 equals 2. So what we know about that is x equals 2. Again, I'm totally aware that some people do it differently to me, and they use like a line going down the equal sign, and they change side, change the sign, or they repeatedly do the same operation both sides. If your method works for you and you're getting the right answers, that's brilliant. If not, I think my way is quite straightforward. Okay, so this next part is where we're going to be doing x's on both sides. If you've not seen these before, it's pretty much what we've just done. It's one additional step. Okay, so what we're going to be doing now is solving an equation with x's on both sides. Now, our method for two-step equations can be used, and again, if you've got your own method, that's also fine. Demonstrate how we do it. It's one additional step. What we need to do is eliminate the smallest term in x. So I think, what's the smaller out of 5x and 3x? It's of course 3x, right? So we're going to eliminate it by taking 3x off. Remember, equal sign is a balancing act. Whatever I do on one side of the equal sign, I must do the same thing to the other. So I've got to take off 3x on this side. So that leaves me with 2x on the left-hand side. Not done anything with the 5, so that stays where it is. The 3x is now gone. I've taken that away. But I've still got that plus 17, or just 17. It's now a two-step equation, exactly the same as it was before. So now we'll just start with the 17, do the opposite. Take off the 5, leaves us with 12, and then we divide it by the 2. So then 12 divided by 2, that's a 6. So what we can say is that x equals 6. And there we go, that's how we do it. I'll do a few just to make sure we've definitely got this. So 6x minus 5 equals 3x plus 10. Remember, step 1, and the only additional step is getting rid of the smallest term in x. So what we'll do is we'll take off the 3x here, which means we've got to do the exact same thing over there. So 6x take away 3x leaves me with 3x. Not done anything with minus 5, so that stays put. On the other side, I've just got that 10. Alright, so using that, work on backwards, start with a 10, do the opposite, add on the 5, gets us 15, and then we do the opposite, we divide by the 3. So 15 divided by the 3 gets us 5. So what we know is that x must equal 5. Okay, that's the method we can use. Do another one. Okay, so this time we've got 6x minus 5 is equal to minus 3x plus 40. Trick you on this one because here we've got minus 3x. Now to eliminate that, what I've got to do is I've got to add 3x on, effectively to make that a 0, because minus 3x and 3x gets you to 0. So what we're going to do is we'll add 3x on this side, which means we do the exact same thing on the side, we add 3x on there. That gives me a total of 9x minus 5, all equal to, so remember that adding 3x on is cancelling out this term in x on the right hand side, so we're now just left with 40. And from there, start with the 40, do the opposite, we'll add on the 5, gets us 45, then we do the opposite, we divide by the 9. So 45 divided by 9 gets us 5. So for that one, we know x must equal 5. One step up again, this one involving brackets. So again, it's the same process, it's just one additional step to what we've just done. We've got to expand the bracket first. So expand the brackets, so we get 4y, 4 times minus 2 is minus 8, all equal to 2 times y, or 2y, 2 times 3 is plus 6. And then again, get rid of the smallest unknown, in this case the 2y, so I'm taking 2y off both sides. So what I'm left with is 2y minus 8 is equal to 6. And then work it backwards from there. So start with the 6, we'll do the opposite, we'll add on the 8, gets us 14. Then we've got 14, do the opposite, divide by the 2, gets you 7. So this one, we know that y must equal 7. Okay, I'm going to do one final example, and this one's quite a tricky one. It involves effectively fractions on both sides. The easy way to clear it, I'll demonstrate. So where you've got the divisor of 3 on the right hand side, what we'll do is we'll move the 3 to the other side, and we'll just go x 3 plus 4. And then on the other side, we're taking the divisor of 2 from the left hand side and multiplying everything by 2. So that gets us 2x plus 10. And again, from there we expand the brackets and we solve it. So that's going to get me 3x plus 12 on the left hand side, 2x plus 20 on the right hand side, and then get rid of your smallest term x. So we'll take 2x away from both sides, leaves me with x plus 12 on the left, leaves me with 20 on the right. Just to make that clear that that was x plus 12 there. So then working backwards, 20, do the opposite, take away the 12, leaves you with 8. So x must equal 8. Again, I would heavily stress and emphasize on that that question is probably more difficult than what you will find on a foundation GCSE paper, but it is listed on the spec, so I've included it there just in case. Right folks, so what's going to happen next is we've got the second set of revision grids. So when the slides appear, press pause, attempt the questions, then I'll talk you through the answers. Okay, pause now and attempt the questions. Okay, so for the first one, what we have is a compound shape, so we need to split this up a bit. We need to think, well, the area of this shape here, the one on the right, that's rectangle 3 by 1, so that's going to be an area of 3. Now, what we know is that the entire shape, all the way from here, all the way across that way, is 5 centimeters. This is 3 centimeters, meaning this is going to be 2 centimeters. So we have an area here, again, I'll emphasize, not drawn to scale, it's 2 centimeters by 2 centimeters. The area's got to be 4. And then if we add the two areas together, 4 and 3 gets 7. Working in centimeters, we're talking about areas for 7 centimeters squared. Next up, it says sketch a reflex angle and a right angle. A bit tricky for me to do using this, but the right angle would look like that, where it's exactly 90 degrees. A reflex angle, if you take an obtuse angle or an acute angle, and instead of going on the inside, you go all the way around the outside, that would be a reflex angle. So it's anything that is over and above 180 degrees. Next up, sketch a triangular prism. So remember, triangle and then a prism. And a prism is anything with the same cross section all the way through. So it would look a little bit like that. Next up, reflect the shape. Awkward one, this, because the reflection line is on a diagonal slant, but I think that point there is 1 square across on the diagonal, so it needs to go 1 square across on the diagonal there to be here. This point is already on the mirror line, so stays put, and this one is 2 squares across on the diagonal, so carry that along to here, and there's our reflection there. Next it says name the shape. There's a hint there, it says 2 sides are parallel, so if we assume it's that one and that one, we've got 2 parallel sides and 2 non-parallel sides. That makes it a trapezium. Next up, how many lines of symmetry does this shape have? Try my best to draw it in. There's 2. You've got one this way, and you've got another one, do it in a different color, coming this way. So there's 2 lines of symmetry with that particular shape. Next up, sketch the net of a square-based pyramid. Well, assume that that's a square, and then you would have 4 triangles coming off as the net. So imagine that you had a pyramid and you flattened it out into a 2D shape. Next up, enlarge the shape by a factor of 3. So remember, that means we're making the shape 3 times the size. So currently it's 2 squares wide by 1 square high. So we need it 3 times as big. So we want 3 squares high. We want 6 squares across. And again, for the purposes of this particular kind of question, the enlargement can be anywhere. When we do enlargement around a point later on in the year, that will change. And then finally, it says calculate the area 3.5 centimeter high by 5 centimeter wide. Remember, that's a triangle. So remember, it's base times height and then half it. So I think 3.5 times 5 would be 17.5. Half of 17.5 would be 8.5. So just to be clear, that was 3.5 times 5, all divided by 2. Remember, 3.5 times 5 gets us 16.5, sorry, and then 16.5 divided by 2. I think half of 16 is 8, half the 0.5 will be 0.25, and we're working in centimeters, talking about area, so unit is centimeters squared. Finally, we've got the data and stats grid. So I'm going to start with this question up there. It says provide one comment on the graph and what it shows. Well, it shows exam scores versus attendance. So we just write that. It's effectively the title for this one. So exam scores and attendance. How many students were in the class? Well, we can count how many dots were there. So let's have a look. 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12. So there was 12 dots on the graph. So 12 students or 12 bits of data in there. Next up it says if the pass mark was 50%, what is the probability of a student passing? So the pass mark is this line here. So anything that is on or above that line is a pass. So that's 1, 2, 3, 4, 5, 6 out of a possible 12. So there's a probability that 6 out of 12, which simplifies down to a half. So you can say it's a 50-50 chance of passing, or 50%. Next up, it says circle the result you are most surprised by and state why. Well, that's going to be this one here, because as you can see, they've attended very little, but they've got a very high score. It's called an outlier, or occasionally some other subjects say science would refer to it as an anomaly, but either would be fine. That's the one for it. Next it says what's the modal average for attendance. So we're looking for what the most common attendance score. So you remember your attendance of the scores going across the bottom this way. We've got 2 in under 10%, we've got 3 under 20%. So that one's going to be the most common one. So the modal average for attendance was 20%. And that's the data and stats grid. Right folks, so that was the lesson on solving equations with unknown on both sides. Again, any problems, any questions, refer them to your tutor in the first instance. Please do attempt the work on Canvas and let us know if there's anything else you would like to see or get any more help with.